The power of compounding. So I encourage you to take a moment, pause the screen, and read over this blueprint. Okay, now let's go ahead and start solving, and we'll apply these rules that were above. So we're going to evaluate the following. We have 3 on a 1a. We have 3 raised to the power of 4. There's another way of looking at it. You can say, oh, that's the same as 3 times 3 times 3 times 3. 3 times 3 is 9. 3 times 3 is 9. 9 times 9 is 81. That's one way to look at it. Another is just 3 to the 4th. But anyways, b is raised to a negative power. However, we can't have a negative power in our final answer. So anytime we have a negative power here, we know that we're going to write its reciprocal. This will make it a positive power. If it was 1 over 3 raised to negative 2, then that means it would have been 3 squared, right? Okay. Now let's go ahead and finish it up. We got 1 over 3 squared, which is 1/9. Whenever we multiply like bases, a base is raised to some power. Okay, whenever we multiply like bases, we add the powers. So I have 2 and 2 for a base, so they're like. That means the power on this first 2, we're going to add it to the power on the second one. So now I got 2 raised to 3 plus 4, which is 7, so 2 to the 7th. And a way of looking at that is 2 times 2 times 2 times 2 times 2 times 2. 1, 2, 3, 4, 5, 6 times 2. Make it say this is 8. This is 8. So we got 8 times 8 is 64, and then multiply it by 2 because we still have this 2 right here left, which is 128. Now let's talk about dividing. Whenever we divide by like bases, we subtract the top power minus the bottom power. So I have 3 raised to 4 minus 2, which is 3 squared, because 4 minus 2 is a positive 2. And my final answer is 9, because 3 squared is 9. You should always simplify if you know that, because like x, we don't know its value, but we do know the value of 3, so always simplify. Now let's talk about this. E has got some base raised to a fraction. A fraction tells me we have some type of root going on. And when we look at the bottom of the fraction, that tells me the root, right? That is a square root, so we know that. The number on top in that fraction is my power. So that 25 is raised to the first power. So I have 25 raised to the half, which means square root of 25. And I'm going to divide that by 25 raised to a negative half. So what does this tell me? It tells me that I need to rewrite this in the format that power is positive and not negative. So I got 25, the square root of 25, all raised to a negative 1, right? Well, since it is a fraction division, you know, it's the top power minus the bottom power. We can have a different answer there, but let's go ahead and solve for it like this, just for now. So I have the square root of 25, which is 5. The square root of 25 is 5. And this is raised to negative 1. So I'm going to rewrite it as 5 times, because I'm going to bring it up to the top, right? So now I got 5 times 5, which is 20. All right, we're adding 2 cubed to 3 cubed. So in adding and subtraction, we can't put things together. They're not like terms, and these are not like terms, but they do have like powers, but they're not like terms. So 2 cubed is 8, and 3 cubed is 27. Again, that's just 2 times 2 times 2 plus 3 times 3 times 3. When we add those together, we get 35. And that's my answer. All right, moving on. Let's solve for the unknown. So on A here, y is my unknown. To get it by itself, I need this 4 to be on the other side. To make it go to 0 here, since it's positive, I'm going to subtract it. So I have y equals 7 minus 4 is 3. Over here, I have a coefficient of 2 on x instead of positive 1. So to undo that, I need to divide. So x is equal to 18 divided by 2 is 9. C, we have a constant and we have a negative coefficient on y. We need it to be a positive 1 and it's not. So first things first, let's get this constant to the other side. It's positive, so I'm going to subtract it. And then it leaves me a negative 6y equals 13 minus 1 is 12. Now I have a negative 6 coefficient on y. I need it to be a positive 1. So that means if I divide by negative, negative divides negative is positive. 6 goes into 6 once. What I do to one side, I'm doing to the other. Negative 6 goes in positive 12. Negative times 6 goes in 12 2 times. So let's solve this one. I want all my constants on one side and my variables on the other. So I'm going to move this 6x because I like my variables on the left-hand side. Since it's positive, I'm going to subtract it. I'm going to subtract this 5 to get it over here. That goes away and that goes away. So now I got negative x minus 6. So it's like saying you're in the whole $4. You spent 6 more. So now you're in a whole grand total of $10. You're in the whole $5. You spent 5 more. You're in the whole grand total of 10. And now let's divide by this negative 10 to get a positive 1 coefficient on x. Negative divides negative is positive. 10 goes into 10 once, and that's my answer. Okay. Let's move on. All right. So let's solve for this one. First things first, I see that I have this variable term and this variable term, and we need them both on the same side, right? We need to put them together if possible. Another thing is I see that this is a fraction. So to undo this fraction, because I get x is involved with the fraction, I have to undo the fraction. So if I multiply this whole entire thing by 3, that means 2/3 x multiplies by 3 plus 4 multiplied by 3 equals 2x times 3. If I do that, I undo the fraction, leaving me with 2x plus 12 is equal to 6x. Now let's move all the variable terms on one side. So I'm going to subtract the 6x from both sides, which gives me a negative 4x. I'm going to subtract this 12x from both sides. Or excuse me, there's no x, it's just 12. And now let's divide by that negative 4. So now I got x is equal to 3. And that is my answer for that one. All right. On this one here, I have y raised to the cube, and I need y to the first in order to tell you what y is. To undo the cube, that means I'm going to take the cube root of both sides. And since it's an odd root, we're not going to take a plus or minus of the other side. So this is another way of writing it, is this power over this root, which gives me 1. That's what I wanted, right? The cube root of 27 means that whatever is inside there needs to be raised to the cube, right? The powers in the root reduces. 3 times 3 times 3 is 27, so my answer is 3. I want you to take the time to do G and H on your own, and we'll talk about that in class. Take a minute, read this. Okay, let's get started on our next example. It says, while banks almost always pay compound interest, bonds usually pay simple interest. Suppose you invest 1,000 in a savings bond that pays 10% simple interest per year. How much total interest will you receive in 5 years if the bond paid compound interest? Would you receive more, less, or the same amount of interest? So we take that 1,000 and multiply it by, and we need to convert the percent to decimal. and that gives me 100. And I want to know for 5 years. So I'm going to take that 100 and multiply it by 5. And it says in 5 years, my interest should be $500. And then ask yourself, is it more or less or the same if I was to compound it or not? So just think about it. That's a critical thinking discussion one. Let's move on. All right, let's fill in this table. It says that you invest $100 into 2 accounts, each pay an interest of 10%. One is pay simple interest and the other pays compound interest. Make a table to show the growth of each account over 5 years and compound the interest formula. All right, so let's talk about it. The simple interest, we're going to, let's do this one. Take that $100 right here. So we're going to take the 100, multiply it by 0 or 0.1, which is what, 10. So we know it's going to be 10, right? For all 5 years. Now, when I do that, that's 10 plus 100. And then it's going to go up 10 every year. That's just simple interest, right? So it's a total of 50 years over 5 years, or excuse me, $50 over 5 years, giving you a total of 150. Now, when we do this other one over here, compound interest, let's double check. I did give you all the formulas for these, right? I'll have to give you the formulas. Here we go, right here. Compound interest. Okay. Let's do this. So what do we start out with? We compound at $10. We're going to get 110, right? And then we will take that 110 and multiply it at 10%. Gives me 11, right? Then we add it on, so 121. We take that 121, multiply it by 0.1. So when I multiply it by 0.1, I get 12.1. We're going to add 12.1. We're going to take this one and multiply it by 10 again, or 0.1, 10%. And you'll kind of see where we're going with this. So the grand total for that 5 years is $61.05. So the total at 5 years would be $161.05 off of $100. And if you needed to, write out to the side again, that 100 times 0.1 gave us 10. That's where we started. Okay. All right. Moving on. Ariel deposits $5,000 in an account that earns simple interest at an annual rate of 3%. Travis deposits $5,000 in an account that earns compound interest at an annual rate of 3%. Compute the following table to show the performance of these 2 investments over a 5-year period. Round all figures to the nearest dollar. All right, let's do this. So we have $5,000 at 3%, right? So we take that $5,000 and let's multiply it by 0.03, which is 150. So if you need to do the math work on paper, we had to convert that to decimal. It's 150. Okay, so we're doing the simple here. So this does not change, right? It's just a simple interest. Well, knowing that, add the 150 to the 5,000 gives me 5,150. Add 150 to this here, and it gives me this. Add the 150 to this here, gives me this. Just keep adding the 150. And this is our simple interest, right? Oops. Add them all up. Now let's figure out this other one. Okay, we're going to compound the interest. We are starting at 150. We'll start at 1,000 or 5,150. And then we're going to take that 5150 and multiply it by 0.03, right? And that's going to tell me my new compounded interest. We're going to add it to that, and it gives me my 5304.5. Okay, we're going to take that 55,304.50 cents, multiply it by 0.3, we get 159.14, right? And then we're going to take that and add it on to the 5304.5. And then we're going to multiply that by 0.3. And we're going to get 163.91. Add it on and get a new amount. You'll kind of see the pattern here. We're going to take this 5627.55, multiply it by 0.03. It's going to give me my new number of this. And then we'll add this on to the 5627.55. Multiply this new number, and you just keep on going if you're going on further. Now let's add 1 through 5 up. Gives me this grand total of $796.38. And we're going to end with a balance of 57996.38. Okay, so again, we multiplied 0.03 to this column to add it back to that column. And then whatever we get, we just kept adding down. Okay, so y'all got the point. So let's go on to our next one. Your grandfather put 1,000 under his mattress for 50 years ago. If he had instead invested into the bank account paying 3.5% compounded yearly, how much would it be worth now? So let's use our formula. Started out with $1,000. We're going to add to our interest, and let's write it in decimal form. We're going to raise it to the power of 50 years, and then type it in your calculator. And I get a total of $5,584.93. So, I mean, at the end of 50 years, only had 1,000, but if he invested into a bank account, would have had $5,584.39 or 93 cents. 93 cents. So read this blue for a second. Take notes. I'm going to use it. This example here, we're going to talk about in our class discussion. Let's do this one. Use the appropriate compound interest formula to compute the balance in the following accounts after the stated period. So A says 20,000 for 5 years with the APR of 3% compound daily. So let's solve for it. So we have A is equal to the 20,000, 1 plus, we're going to write this in our interest in decimal form. And we're going to divide it by 365 because it said compounded daily. Raise it to the power of 365 times the 5. Let me write this formula down because it was right above when we started this. You can call it APR. APR over N raised to N times T. All right. So I'm going to clean up the parentheses first. 1, 2, 3, 4. All right, so I have 1 plus this fraction, 0.03 divided by 365, which is 1.000082192 raised to 1,825. All right, so let's just get our final answer. All right, so I came up with a total of 23,236.54. So this one here, we're going to talk about in our class discussion. This one here, we're going to talk about in our class discussion. Let's do this next one. So we got 15,000 for 20 years with the APR of 3.7% compounded quarterly. So we have A is equal to 15,000. 1 plus 0.037 over 4 because it's quarterly, right? And there's 4 quarters in a year, raised to 4 times 20 years. Let's compute this. So we get a total of $31,332.27. Yay. All right. So I want to do this one in our discussion, and let's go to this one. So 25,000 times 1 plus our APR compounded annually divided by 1 raised to 1 times 30. And what do we get here? And I got 85,895.73. Okay. Very good. So let's move on. Take a moment to read that. And let's solve for the next one. It says you deposited 1,000 into an investment with an APR of 8%. Find the annual percentage yield with quarterly, monthly, and daily compounding. All right, so let's figure this out. So if I have an annual interest of 8% and our principal is 1,000, let's figure what that would be if we was to do quarterly, monthly, daily, and we're compounding this. All right, and you were given formulas right up here. It says affected yield, okay. So I have, what, 1,000 times that 0.08. That's 0.08 divided by 1,000. Let's come up here. My apologies. I'm just working out my numbers right quick. So when we figure out the quarterly, we're going to get 82.43. And the annually we get 83. And the daily, or excuse me, the monthly we get 83, quarterly 82.43, and the daily we get 83.28. Okay, so now when I figure the APY, I end up with 0.08243, and which is at 8.243%. My APY is 0 for monthly, 0.083 with a percentage of 8.3. My APY for the daily is going to be 0.08328. And for my APY percentage, it's going to be 8.328. We'll practice on these more in class. All right, we are almost done, guys. So our next one says, you deposit 1,000 in an account with an APR of 8% and continuous compounding. What is the value after 10 years? So I got A is equal to 1,000, E raised to that 0.08, this percentage in decimal form, times 10 years. So on your calculator, you're going to have to use the E button. Okay, so it gives me a total of 2,225.54. So I want you to do, we're going to do this number 5 here in class discussion. Okay, let's do 7. Suppose you put money in an investment with an APR of 3% compounded monthly and leave it there for the next 18 years. How much would you have to deposit now to realize 100,000 after $1,100 after 18 years? Okay, so what we're going to do is our end goal is the 100,000. So my A is actually that 100,000. So we're going to set this up a little bit different. We don't know what we need to invest. That's the P. We've been investing P this whole time. We don't know what it is. We do know that our APR is 3%, which is written in decimal form of 0.03. It says we're going to compound monthly, right? So N is 12, and we're going to do it for 18 years. So our formula will look like this. All right, so let's solve for it. We're going to solve for P. Well, to do that, we need to clean all this up and then move it over. So what I would do is go ahead and get this parentheses taken care of. So I come up with 1.714850874. And I would divide both sides by that 1.7. And we are going to come out with a total of 58,314.11. And now our last one. So how long will it take your money to grow by 50% at an APR of 7% compounded? All right, well, let's just do this here. Let's come up here. So I got A is equal to P1 plus APR over N raised to NT. My A is going to equal the 100. 1 plus 0.07 because that's going to be converted to decimal. And this gives me 196.72. Okay, so we're trying to figure out how we're going to come up with it, right? So and then next I'm going to take the A equals the 100. 1 plus 0.07 raised to 7. And that gives me 160.58. And let's say, okay, well, let's do 5 years, we're going to keep going. Which gives me 140.26. And what if we did 6 years? It's 150.07. So it looks like after about 5 years, we'll get that's how about after 5 years will be our answer.